wood and making objects by hand can be very satisfying. Whether it be professionally or just for fun, personally, I always enjoy projects that stretch my creative skills. Incorporating curves and using veneer are the two elements that really push my ability, as well as add what I feel are the most striking aspects to any object made out of wood. Here's an example that dramatizes my point. Let's say this piece of mahogany will be a drawer front in a piece of furniture. I'm sure it would be quite attractive just as is. But let's take this flat drawer front and add some curve to it. To me, this drawer front has movement. It's more alive than the flat one. Now, let's add a second element, veneer. Instead of just regular mahogany, let's incorporate some mahogany crotch with a short grain border. This adds a whole nother dimension. To me, this drawer front is so much richer and more alive than this flat one. And this is where a vacuum press comes in. Hello, my name is Darryl Keel, and I've been a woodworker for many years, as well as more recently, president of Vacuum Pressing Systems. We have put together this video to practically show you how a vacuum press can incorporate curves as well as curve veneering into your work. I will demonstrate step by step a wide variety of items that vacuum can effectively laminate and veneer. Now, a vacuum press is a great tool for pressing just flat panels like this walnut burl tabletop. But where vacuum's ability really stands out, and what this video will focus on, is curved work. Parts like this round column, this maple burl cove molding, or this Macassar ebony bullnose panel, as well as other shapes, would be very difficult and time-consuming using other means. How about this curve jam? With a vacuum press and a little know-how, all of these items can be successfully pressed quite easily. In this video, I will thoroughly explain and demonstrate how to create these things as well as other items so you can maximize vacuum's potential in your own shop. Well, we've got a lot to cover, so let's get started. One thing I did want to mention, because this is an advanced veneering video, I don't plan on covering any of the basics of veneering or of vacuum pressing. You may want to consider our first video, Working with Veneer, for the more basic skills. The first project I would like to demonstrate is how to create and veneer a curved panel. Now, the first step in this process is creating a form the curved door will be pressed on top of. The most important thing when building a form is understanding the kind of force vacuum can apply. A form improperly built can distort or completely collapse under full vacuum. I can't tell you how many of my customers have crushed or imploded forms not sufficiently braced. I'd like to show you this simple demonstration that dramatizes what I'm talking about. I have this piece of 3/4 inch particle board, approximately 12 inches by 14 inches, which I'm going to put on these two blocks, slide into the bag, put on the closure, and turn on the pump. Watch what happens. That's the kind of force vacuum can apply. With that in mind, let's go back to the construction of our form. Not only do you want to prevent that, you really don't want any deflection at all. Otherwise, your finished panel can come out uneven or even rippled. There are basically two methods for properly supporting the form. The first method is placing ribs down the form at certain intervals. How far apart depends on how thick the skin material is and how many layers will be used. I recommend 3/8 bending plywood. This plywood is specially made to be very flexible in one direction, but fairly rigid in the other. There is an 1/8" bendable plywood, but your ribs would have to be placed so close together to prevent dishing between them, the form would become almost solid ribs. Here is the formula I use for rib spacing with 3/8 bending plywood. Ribs every 3 inches on center with 1 layer of 3/8 bending ply, or every 6 inches on center with 2 layers of 3/8 bending ply. I prefer my ribs every 6 inches on center with 2 layers of bending ply because it cuts down on the labor of making the extra ribs and the form stays considerably lighter. I stand my ribs up on a sheet of 1/4 inch plywood, which makes the skin easier to put on later. 2 things to remember. First, every rib must reach all the way down to the 1/4 inch plywood bottom. A rib that looked like this would allow the vacuum pressure to implode the bottom of the form as well as the groove platen up into this unsupported area. Remember the earlier demonstration. The other important point is lateral end bracing like these you see here. This step is often overlooked, which result in the end ribs blowing inward. As a rule, this bracing is only necessary if the end ribs are more than 6 inches tall. The accumulated force vacuum applies is usually not a problem on lower profile forms. These ribs I place about every 8 to 10 inches on center and are only needed between the outside rib and the next one in. It forms a sort of torsion box. Let me put these 2 layers of 3/8 bending ply on this form. Now that the skin is applied, I need to provide a way for the air to quickly get out of the form. If it can't and has to work its way through the cracks and joints, the pump will probably cycle erratically. I do this by running the form on the table saw with the ribs perpendicular to the saw blade, which is set just higher than the thickness of the 1/4 inch bottom. This groove will allow the air to get out of each cavity. Now, a version of this form building method uses expanding foam between the ribs, allowing them to be placed farther apart. These ribs are 12 inches apart with only 1 layer of bending ply. This foam was squirted here and expanded to fill the cavity. I'll take a handsaw and cut this off flush with the bottom of the form. This product is obtainable through most lumber yards, but remember there are 2 types, minimal expanding and regular. Make sure you don't get the minimal type or you'll use twice as much. You can get this in larger quantities and whole systems that expand even more. I don't tend to use this method, but I just wanted to show you the concept. One thing about this type of half-round form, no matter how you brace it, is making sure you add a couple of inches to the bottom. If your laminations go to here, you want to add some extra because the bag will always sweep away from the form near the bottom, and you won't get good side pressure in this lower area. Another method of form building uses rigid foam, which eliminates ribs altogether. I used this 2-inch building insulation and hot melt glued each piece to the next. To compensate for any discrepancies between the individual pieces, I glued an 1/8" bending ply skin to the surface. This takes care of any slight variations. You can get this material in thicker dimensions, but I just grabbed what I had on hand. Although I tend not to use this foam technique much because of the bulk disposal issues, it sure makes for an awful light form. Now, the method I like of supporting a form is, oddly enough, using vacuum against itself, so to speak. This is accomplished by using a product I call an AirForm. Let me explain. An AirForm is just another bag that goes inside the form and inflates itself under vacuum to provide internal pressure against the outside pressure bearing down on the bag. Still confused? Let's go back to that earlier demonstration where I snapped that piece of particle board in half. I'm going to do that same demonstration except with the AirForm underneath the board. Let's take a look. I'm going to place this small AirForm underneath this piece of 1/2-inch plywood. Notice that it sticks out both ends. This hose goes from the AirForm and connects to this nipple on the bag, giving it access to outside air. Now I'm going to seal up the bag, turn on the vacuum, and put my thumb over the hose that goes to the AirForm. Watch what happens. As before, the board begins to dish under vacuum pressure. Quickly, turn off the pump before it breaks. Now, let me take my finger off the hose and watch what happens. The outside air rushes down the hose and into the AirForm, equalizing the pressure inside with the pressure outside the bag, bringing this particle board back to normal. The beauty of this technique is the greater the vacuum pressure on the outside, the more the AirForm automatically draws air in to balance the internal pressure. It's basic physics. A form that uses an AirForm would look like this. Those 6 inches on center ribs are unnecessary. Only a few of these 3/4 by 3/4 inch arched ones are needed, just enough to hold the skin in the shape you want. The advantage of this method is obvious. It cuts down dramatically on the material and labor and keeps the form quite light. Whichever method you use, make sure your form is straight and square. The door will only be as good as the form. There is another reason the form should be square, which I will explain later. Now that the form is ready to go, let's lay up the curved panel. The 3/8 bending ply I used for the skin is the same material I will use for the panel itself. I could use this 1/8-inch bending ply for the door, but 2 sheets of the 3/8 and I've got my desired 3/4 of an inch. I'd need 6 layers with this 1/8 inch. Sometimes I put a sheet of 3/8 in the middle with 1/8 inch on both sides. This gives me a smoother final surface to put my face veneer on. This time I'm using 2 layers of a 3/8 bending ply with a single sheet of backer grade veneer between them, with the grain going 90 degrees to the bending ply. I always try to run each layer perpendicular to the next whenever I can, especially with this 3/8 material. It's rather coarse. I'm going to glue the final face and backside veneer later in a second operation. I'll explain why at that time. Notice I'm leaving the veneer tape on the backer veneer and will sandwich it between the bending ply. This is a special veneer tape meant to go on the glue side of the veneer. As long as these center row of holes are directly over the veneer joint, it will work as well as veneer tape on the face side. I don't use this in all situations, but it does come in handy. Before we actually glue this up, I need to take a few minutes and talk about glues. The type of glue used is one of the main factors that will determine the long-term stability of the panel. So understanding the choices and picking the right one is important. First, let's look at what we want to achieve with our panel, and then I'll examine the different glues. The most important consideration is panel stability. When the panel is taken off this form, I want it to stay in this exact shape. I don't want it springing back even a little bit. I also need to consider how long it's going to take me to lay it up. Some glues have a very short open time, and on a large panel, I may not have enough time before the glue begins to tack up. Now, the glues I consider, I've put in these categories. Semi-rigid and rigid. In the semi-rigid category are PVAs, commonly called white and yellow glue. In the rigid category are urea resins, epoxy, and polyurethane. The main difference between these two groups is the way they achieve their final cure. The PVAs cure by the evaporation of water. Rigid glues cure by catalyzation. Part A is mixed with part B, and after a certain length of time, the glue is cured. Even this polyurethane cures by catalyzation, except water is the catalyst. Because of this, PVAs do not achieve the same hardness as the ones in this rigid category. These glue samples help to dramatize this point. I previously poured these out and let them dry completely. If you look at these samples of yellow glue from the PVA family, you will notice that it has some flexibility. This urea resin glue from the rigid group is very hard, even quite brittle. Let's add even a small amount of heat provided by this heating blanket, which would simulate, let's say, a piece of furniture receiving direct sunlight. This yellow glue becomes quite flexible. Look at that, extremely flexible. But the urea resin is just as rigid. With this basic understanding, let's examine two other considerations. Panel stability was our first point. Because PVAs have some flexibility, they can allow a panel under strong tension to spring back somewhat. And because of their higher shrinkage, as they dry, they can actually cause a panel that easily conforms to develop a tighter radius as they dry, called toe-in. Here's a sample I pressed on this form a few days ago with yellow glue. Look how it's touching on the ends, but there's a gap here in the middle. This is an example of toe-in. Rigid glues are your best insurance against these conditions. Rigid glues also have a much longer open time, which is usually advantageous on curved panels because there are multi-layers. On this panel, we have only 2 glue lines in the first layout, which I could apply fairly quickly, so I could use a yellow glue. But because I want the maximum stability, I'm going to use the urea resin glue. Before I mix up the glue, I'd like to talk about bag access. When you're by yourself, trying to hold the bag open while sliding your project in at the same time can be a real problem. I have a couple of simple techniques to take the hassle out of bag loading. See this cord hanging from the ceiling? I use this like so to keep the bag open. Now I have my hands free to load. The other thing I have is this rolling table. I can roll out my glue on this table, slide my panel onto the rolling cart. Because this cart is a little higher than the pressing table, I can just slide it right into the bag like this. With these two aids, I never have a problem loading by myself. Now let's mix up the glue. I'm using a 2-part urea resin. With this one, the resin is a liquid and the catalyst is a brown powder. Because it does contain some formaldehyde, I'm going to use this respirator. Oh, one last thing. I like to put registration marks on the center of my form as well as on my plywood. This way, I know it's set square and centered on the form. There. Now I'm using an inexpensive foam roller instead of my nice glue spreader because this is a catalytic glue. And if I forget, this nice glue spreader that I really like is history. Okay, everything's marked, glue's mixed, let's lay up the panel. This 3/8 bending ply is quite porous and really soaks up a lot of glue, so I'm rolling a heavy coat. Place it on the form, make sure my registration marks line up, and put down a few strips of masking tape to keep things from sliding around. With this form, I'm using the AirForm, which I have already placed inside. I'll slide the form into the bag and hook it up to the outside air. And hook it up to outside air. Now, although it will inflate itself, I like to give it a head start by pre-inflating it a bit. I'll hook this up to the exhaust port on my pump and blow it up like this. That's plenty. Disconnect it so it can self-adjust, seal up the bag, and turn on the pump. One nice thing about vacuum is you get to watch what's going on, so there's always time to adjust things if you see a problem. Sometimes I hear people wanting a really large vacuum pump so it will suck things down almost instantly. I think this is a bad idea. No time to make adjustments. Remember, the speed of the pump is more about staying ahead of the glue's tack time than anything else. That's another reason I prefer a slower setting glue. I'm not in a rush. There it is, all sucked down and the pump is shut off. It will recycle when needed. It looks real good and nothing has slid around. The AirForm has perfectly balanced the internal pressure. While this is curing, let's talk more about Two-Plies and why I chose not to put the face veneer on in this layup. Now, a Two-Ply is exactly that. Two pieces of veneer glued together with their grain going 90 degrees to each other. This is really a very thin sheet of plywood. The advantage of Two-Ply in curve work is threefold. First, you get to pre-press this veneer in the flat before putting it on the curved panel. In this way, you can examine the Two-Ply and make sure it has been successfully pressed. If you find an area that didn't press properly, you can go around the back side, make a small slice, inject some glue, and repress that area. Even if the whole pressing on the Two-Ply was a failure, at least you don't have to throw away the entire panel as well as the Two-Ply. The second benefit is that since this Two-Ply behaves more like plywood now than veneer, If I press it onto my curved panel, let's say I have a few areas, even the size of, let's say, a quarter, that don't adhere properly, I really don't have to be concerned, since it will not transfer through to the face veneer. If this situation was just the face veneer alone, we would have a real problem. Little bubble areas would show up. The other thing is, because this is fairly stiff, now I can pre-sand it in the flat, which is much easier than if it's on a curve, especially an inside curve. If you have a wide belt sander, you can even double sticky tape the leading edge of this two-ply to a sheet of, let's say, MDF or particle board and send it through. Saves a lot of time. I call two-ply curved panel insurance. No surprises. It's been a few hours, and the glue has set up enough for me to take this panel out. Let's take a look. Looks good. It's sitting pretty good on the form. One quick thing before I take it off the form. I'm going to make a little mark here on the panel and here on the form. I want to be sure when I put it back in to press the two-ply face veneers, I put the panel back in the exact same location. If I accidentally switch this panel around, it might not mate with the form as well, and I could get a poor bond between the back side of the two-ply and the form. I prepared this two-ply earlier, so I'm ready to go back into the bag with the final pressing. I'll apply the glue, put it in the bag, hook up the AirForm, and turn on the pump. That looks real good. Now, I usually place some kind of cover sheet between the bag and the face veneer, like, let's say, 1/8" bending ply, or maybe plastic laminate. With two-ply, this is unnecessary, since the face veneer is already pre-stabilized. It's the next morning, and this has had a chance to cure. But before I take it out, let me show you another bendable core material. It's this resin-impregnated paper honeycomb. It's quite flexible, making it excellent for curved panels. This material comes in two types, skinned and unskinned. For curved work, only the unskinned is usable, since the skinned type does not allow it to bend. Here is an example of a panel pressed with honeycomb. I have used 1/8" bendable plywood as the skin material. This blocking goes around the entire edge of the door, preventing the honeycomb from crushing on the edges, as well as to provide a surface for mounting the hardware and applying the edge treatment. The beauty of using honeycomb is that it's extremely lightweight and very stable. One thing to remember, this material comes resin impregnated and just raw paper. Use the impregnated type, since the vacuum press will crush the raw paper type. Now let's take out our panel. I'll open up the bag. Disconnect the AirForm. And take the panel out. There, this looks real good. No spring back at all. Now, most people would think we finished the hard part, and this is true to some extent, but this panel still needs to be trimmed to size, which can be more difficult than you might think with these curves to deal with. Let me show you how I do it. Remember earlier when I said make sure this form is square and true? Now is where it matters. I use this same form to do all my trimming on. For trimming the top and bottom, I use a router with a flush trimming bit. I clamp the panel to the form, overhanging one end like this, using the form itself as the surface for the bearing to ride against. To trim the long way, I use this form as a sled on the table saw. I tip the blade until it's 90 degrees to the panel and run the form and the panel through the saw like this. Remember, the success of this technique depends on the accuracy of the form. There it is, all trimmed square. Let's go on to the next topic, which I call two-step gluing. These two items, this round cylinder and this bullnose edge, use this technique to apply the veneer. Let me explain. I'll start with the cylinder. When people see this veneered cylinder, I always get, how did you do that? The thought being, how did you wrap the veneer all the way around and get a good seam where the veneer meets? The answer is in 2 steps. There's no way I can wrap the veneer all the way around this and expect to get a good joint at the seam all in one shot. The way I do this is to apply the glue to about 3/4 of the cylinder, put the cylinder in the bag with the seam on the underneath facing down. Then, after the glue sets, take the cylinder out, cut the veneer joint, apply a little glue in between, and put it back in the bag with the veneer joint facing up. Let me actually show you how it's done. I've got the actual cylinder ready to go here. Here's the veneer I'm using, which is a very attractive Pomeli Sapelli. The AirForm that will go inside the cylinder, as well as a heavy paper that I will use as a cover sheet. Now, there's one thing I did to prepare this cylinder before pressing. To prevent the excess veneer from snapping off over the edges, I've attached these 1/4-inch extenders on each end of the cylinder with some brads, and then I flush trimmed them back to the cylinder and put on clear packaging tape to prevent glue adhesion. This way, after the cylinder has been pressed, I can pop off these and trim the veneer back to the cylinder. If the cylinder can be trimmed afterwards, then these extenders are unnecessary. I've also put these strips of masking tape on the cylinder to give me a clean line for rolling the glue out, and put marks here where the glue lines will stop. The glued area for the first pressing is about 3/4 of the cylinder. Okay, let's glue it up. For this pressing, I'm using a standard yellow glue. No need for a rigid type on this project. It's fairly small and I can get in so quickly that I don't need a glue with a long open time, and I'm not concerned with spring back or toe in. There, the glue's spread. I'll take off the masking tape, put the veneer on. Note, the veneer overlaps on the bottom. This will be trimmed after the first pressing. Place this piece of heavy paper over the veneer. I'll explain its purpose in a minute. For internal support, I'm using the AirForm again. I could make ribs for temporary support, but the AirForm is so much easier. Let's slide all this into the bag. Hook up the AirForm. Use the exhaust port on the pump to inflate it. There, that should be enough. It'll self-adjust to final pressure from here. Now, I'll turn on the pump and evacuate the air. One thing I need to make sure of is that the bag goes beyond the glue line before it sweeps away onto the platen. The bag is starting to apply pressure. Looks good. While we're waiting for the glue to cure on this cylinder, let me explain more about the heavy paper and what it's for. When this bag begins to tighten around this cylinder, it stretches in this direction. If I don't have something fairly stiff, or at least non-stretchy, between the bag and the veneer, the bag will try to pull the veneer downwards with it. This can result in veneer tearing long way, developing cracks down the length of the cylinder. Something to be aware of. It's been about an hour now, so we can take this cylinder out and go on to the second step. I'll open up the bag, take it out. Looks real good, nice and smooth. Okay, now that the majority of the cylinder is pressed, I can cut the veneer joint and know it will come out tight. First, I'm going to tape the veneer in place as tight as possible like this. Now take a straight edge, clamp it to the cylinder like so, and cut through both layers with this veneer knife. There, that should do it. All I need to do now is peel back the veneer and apply the glue. First, I need to talk about glue for a minute. Now, on the first pressing, I used a yellow glue, but this time I don't want to do that. This yellow glue will cause the veneer to swell considerably, which may cause the veneer to expand so much the joint could overlap itself rather than butt together tightly. A glue like polyurethane with no moisture is what I use for this. The other alternative is to make a two-ply like we made earlier. That you can wrap around the cylinder without any concern because the two-ply is stabilized and high moisture glues will not swell it. I'll pull this veneer back to spread the glue. I use a piece of plastic laminate, and I can get it down in here easily. There. Lay this veneer down, apply some veneer tape to pull the joint tight. Put on a small cover sheet. This time I'm using a piece of plastic laminate a little wider than the glued area. I used the plastic laminate this time, something a little stiffer, to make sure the seam was forced down tight. Slide it back into the bag, re-inflate the AirForm, and turn on the pump. We'll come back to it in a couple of hours. The other project I'd like to demonstrate using the two-step method is this bullnose shelf here. The concept is basically the same with a slightly different twist. On this panel, I've already pressed the flat part, stopping just short of the bullnose. I did it face down in the bag like this, stopping the glue here. You can do it all at once with a feathered caul on top. The flat part of this panel requires a caul to guarantee good results. See the way this sample caul has been sanded down to nothing along this edge? If you put it close to the bullnose, the bag will go off it smoothly and right into the curved edge without creating a ridge here. I prefer to do it in two steps. That way I can concentrate on the curved forming without worrying about the flat part at the same time. One other thing you need to be aware of is which side is up. All veneer bends in one direction better than it does in another, which will form a tighter radius this way. So in this case, I would make this the top side. Now, for the second part of this pressing, I'm going to use this yellow glue specifically because it does have water in it. Because the veneer has to form around this rather tight radius, I'm going to apply the glue directly to the veneer. The water in this glue helps soften the veneer so it will wrap around the bullnose without cracking. I'm also putting a little glue on the MDF. I usually don't put glue on both surfaces, but the edge of this material is so porous I find it just drinks up the glue. The other thing I do is lightly wet the face side with this sponge to assist the bending. Not too much or I may weaken the glue bond on the other side. Now, I'm going to draw the veneer around the bullnose and tape it to the underside. Because the bag will grab all at once, I must have the veneer in position. You'll see what I mean once we turn on the press. Now, I can't just lay the panel in the press like this. The bag won't get down under here. What I do is to slide the panel over here so that the bullnose hangs over the edge like this. I'll take the bag and bring it into position. The idea is to keep the top and the bottom of the bag from coming together on the bullnose. Put this board under here with a few spring clamps. Okay, everything is in position. Turn on the pump. There, it drew down nicely. It's been about an hour. Let's go back and check on that bull nose. It should be ready by now. The cylinder, we're going to have to wait on that because the glue I used has a long set time. All right, let's take a look. This came out real nice. No ridges at the edge of the bullnose. Looks much nicer than having a solid nosing glued on here. The next topic I want to cover is veneering moldings, which requires bending veneer over right angles. I always get, how did you do that without cracking the veneer here? When people see this, it's not really that hard. In fact, with a few simple tricks, it's quite easy. Let's start with this cove molding. First, I want to say that only simple shapes can be done, like this cove, or at most an OG molding. A molding that has intricate detail is just plain too difficult. With this cove, the main trick is the right angles to get the veneer to bend over this edge, down in and over the other edge. I use two simple techniques to soften it sufficiently. Look at this veneer. It's a bird's eye zebra wood. That's what's great about veneer. There's so many choices. I'm not sure anyone would want a zebra wood cove molding, but I think it would look great. First, I apply yellow glue to the veneer, like I did with the bullnose. If that doesn't make it flexible enough, I apply a little water to the top side with a sponge. Again, very carefully. Too much and you'll weaken the glue bond. I'll slide this in the bag on top of a block and do one last thing before turning on the pump. This stick pushes the veneer down into the belly of the cove. Now, I'll turn on the pump. Turn it off again, just as the bag starts to grab. Make sure the veneer is down in position. Looks good. Turn the pump back on and let it pull down all the way. Let me explain about this stick a little further. If the veneer lays across these 2 points and the bag starts to apply pressure like this, the veneer will get locked here, preventing it from conforming in the middle. The result is, as the pressure increases, the veneer will rip right down the middle. By putting this board on top of the bag, I'm assuring the veneer is down in the belly of the cove before the bag grabs it. I've also added this foam strip to this stick, which conforms a little bit better to the shape of the cove. Now let's go on to this OG molding. It's a bit more difficult because of this inside angle, which the bag can't get down into. To accomplish this, I do 2 things. First, I sliced the veneer down its length approximately where the inside angle falls on the molding, like that. Then I ran a piece of veneer tape over the cut. What I have now is sort of a hinged piece of veneer. If you notice, this again is that 3-hole veneer tape. This side will go into the glue. Putting it on the back side makes sure the joint stays tight. I have found that when I put it on the face side, the joint often opens up a little bit. On this walnut burl, I butt joint these two pieces here. Now, at this veneer joint, besides the veneer tape you see on this side, I glued the joint by folding the veneer back and applying some glue. Then I laid it flat and put a piece of masking tape until the glue dried. If I don't do this, there's a chance the joint may open up, considering what it has to go over. Although I have the actual veneer already prepared, I would like to demonstrate how I did this on a sample. First, I'll make the cut where the veneer tape will go. Next, let me apply the 3-hole tape, like so. Now, there's one last thing that's very important for this to work properly. As soon as the tape is applied, you need to fold it like this while it's still damp. If you wait until the veneer tape dries to fold the veneer, the tape will break. Here is a sample that I taped earlier, but has not been folded. Look what happens. It's just too dry now. The next thing I did is to cut a strip of wood that will fit down into this angle. This will assist in pushing the veneer down into this spot. Again, I roll the glue out on the veneer. Next, I'll tuck the veneer into this place. And nail the strip on top. This helps register the cut in the veneer, precisely over the inside angle. Wet the surface of the veneer lightly and put it in the bag. Again, I'll use this piece of wood on top of the bag where the OG dips down until the bag begins to apply pressure. There, looks good. As you can see, this is fairly labor-intensive for a piece of molding. A vacuum press is not for production work. But if you have a cabinet or a single piece of furniture, a veneered molding in some special veneer can really create a nice effect. One other thing I'd like to suggest is this is fairly difficult, and I had to do it a few times to get it right. My suggestion with any of these moldings, or really with anything you see in this video, I recommend do it on a sample first to get the feel of the subtleties that make it come out well. Let's go back and take a look at the cylinder. The glue should be set up by now. Came out real nice. No ripples or bubbles. I'm going to use this envelope liquor, wet this veneer tape, and examine the veneer joint. See how it came out. Take a close look. It came out beautiful. Now, let's step up the difficulty by doing a radiused edge on a round table, basically a compound curve. There's a limit to what can be done, but I want to demonstrate the concept. Veneer, as you know, is a linear beast, which means it will bend in this direction fairly easily, and in this direction somewhat. But in both directions at the same time, it's very difficult. With the help of a vacuum press, combined with some hand techniques, I'll show you how to wrap veneer around an edge like this. Basically, I use the same technique as we did with the bullnose edge, except I add a little hand massaging. Here's a small tabletop out of bird's eye maple that I've already pre-pressed the flat area, so all that's left is the radiused edge. Again, I put the glue on the veneer, like so. Sometimes I blow a little compressed air right there at the joint between the two glue lines, just to make sure I got the glue way in there. Also, wet the surface very lightly. Put it in the bag. And turn on the pump. This foot switch will be handy for this layup. It allows me to turn the pump on and off as I massage the veneer. Massage this a little bit here, especially right in here. This right here on this side grain is actually, surprisingly enough, where you have the most trouble. Although most people would figure it's in here or maybe at the end grain, the biggest trouble is right here on the side. Also, pausing a little bit gives the veneer a chance to adjust. Also, if you've noticed, I'm putting this top up on this piece of rigid styrofoam. This will give me a little bit of elevation so that the bag can really pull down tight on the vertical edge. If you do this little bit by little bit, you'd be surprised how nicely this comes out. All right, I think I've got it. I think we can let it go all the way. Oh, looks great. Now, any last little spots, I can actually massage them down. Now that looks great. Now if you look real closely, you can see how it's all wrinkled right in here, but that's actually beyond the edge of where the curve stops. There, looks real good. I think this example is a real testimony to the versatility of a vacuum press. Obviously, you can't do this on a very tight radius, but it can be very useful on the right project. Be aware of one thing. Some veneers can bend in this way better than others, so you may want to try the veneer you have in mind before you actually put it on your project. The last section of this video focuses on bent laminations rather than veneer. Since a vacuum press is just a giant clamp, solid wood can be pressed just as well as veneer. Two examples I would like to demonstrate is an arched jamb and a stringer for a spiral staircase. Let's look at the arched jamb first. The first thing I need to decide when I'm considering bent lamination work is whether the form will be inside the bag, what I call the inside technique, or whether the form will be outside the bag, what I call the outside technique. Let me explain further. Remember the curved door we laid up earlier? That's an example of the inside technique. Everything went inside the bag. With the outside technique, only the laminations go in the bag. The form stays outside. Another way to look at it is this. Whenever you are creating a bent lamination, there are two things you're doing. One, you are bending all the strips into the shape you want to achieve. And second, you're squeezing all the laminations to each other until the glue dries. With the inside technique, the bag does both parts, forming and squeezing. With the outside technique, the bag does only the squeezing part. When a form gets fairly big, getting into the bag can become a problem. I could get this arched form in a bag, but this spiral staircase form would be impossible. The other benefit of this technique is your form can be very light. Since it's not inside the bag, it doesn't have to withstand any pressure. Most bent laminations are not that wide, so a few clamps are all that's needed to bring it into the form. There's another consideration when using the outside technique, and that's air evacuation. With the inside technique, this grooved platen provides the pathways for the air to get down to the exit hole. With the outside technique, this platen can't be used. Just putting the laminations in the bag directly by themselves won't work properly, since the air has no effective way to get out of the bag. What's needed is some kind of what I call a bleeder fabric. I use this product called EvacuNet. It's a coarse weave screen which allows air to travel down its length. Whatever you use, be sure it's not too fine or the air will have trouble getting out. This fiberglass screen is just too fine for me. In this demonstration, I am using 4 layers of a 3/16 inch solid cherry to end up with a 3/4 inch arched window jamb. Once I've spread the glue on all the layers, I tape the EvacuNet to this face and slide it into one of these narrow lamination bags. Be sure the EvacuNet is on the side that faces the nipple and is directly over the netting, like this. Now, a simple trick to prevent all the laminations from sliding around while I try to clamp them to the form is to draw a very light vacuum on the bag, just about like that. It's not enough to prevent me from bending it around the form, but it holds everything together. I'll put one clamp here in the middle, draw down one side, then the other, and when everything's tight, turn on the vacuum. See, I took care of bringing the laminations into the shape desired, and the bag is squeezing all the laminations to each other. It eliminates all but a few clamps. This next example is a spiral staircase stringer. Anyone who has ever done this knows how many clamps it takes. With vacuum, this is again reduced to just a few. As you can see, I have my form already built. The protruding blocks will help with positioning of the stringer. My stringer consists of 1/8" plywood with a 1/16" skin of mahogany on both sides. For this layup, I'm going to use the rigid type glue. I need a long open work time with so many laminations, and I want a rigid glue to minimize the spring back. Urea resin is the glue I'm going to use on this, as I did for the arch jamb also. I'll spread the glue on all the layers. And tape the evacuum to the top surface. Now I'll slide this sandwich in the bag. Put on the closures. Attach the hose and draw a light vacuum again. That looks about right. I'm going to need an extra hand with this one, so Steve will help me out. He'll climb up the step ladder and hold this at the top while I clamp it in the middle. Now I'll clamp the bottom. And then the top. There, it's in position. Let's turn on the pump and draw down the bag. Looks good. All the laminations are tight and I've got good squeeze out. I would like to take a few minutes and talk about basic pump and bag maintenance. A vacuum press is a very simple system. A pump and a bag. There isn't a lot of maintenance necessary. A few points, though, will help keep your system running in tip-top shape. One thing I want to suggest before we talk about maintenance is running your pump before you roll glue. When I have my project ready to go and I'm about to spread glue, I make it a habit to turn on the pump, draw down the bag with nothing in it, just to make sure that everything is operating properly. There's nothing like the panic of having glue spread on your important project and find the bag is not drying down for some reason. A 2-minute test can avert a major disaster. In terms of pump maintenance, the main thing I recommend to keep it running smoothly is to purge after pressing. This simply amounts to letting it run for about 5 minutes after you remove your project. During a pressing, moisture from the glue is pulled down into the pump. If you turn off the pump and then remove your work, the pump sits with that moisture inside it until the next time you pull it out. What I do is simply leave the pump on, open up the bag, and remove my work. The pump will automatically come on, drawing in fresh air. I let it run for about 5 minutes. This not only purges the pump, but the extra time allows the friction of the vanes in the vacuum chamber to vaporize any residual moisture. I recommend this process even if you have a compressor-driven Venturi type. A pump put away clean, no matter what type, will continue to perform properly. Keep your filter jar clean. Empty the bowl and blow off the filter element. A clogged filter will slow down your evacuation rate and can make the pump cycle erratically. In terms of the bag, I find the most important thing you can do is to keep it covered when not in use, for two reasons. First, exposure to light will slowly cause the plastic to become more brittle. Second, which is more important, is to protect the bag from what is done on top of it when it's not in use. I have found that more bags are damaged by what's done on the outside of them when they're not in use than what's done on the inside. So keep it covered. The other thing I do is spray a little bit of this PAM on the inside of the bag where the closure goes. It's important to get a good seal at this point, and although most glues don't aggressively stick to the bag, even a little glue streaked here will allow air to leak in. This vegetable oil spray meant for cooking doesn't hurt the bag, but it keeps this area glue-free. Also, keep the C-channel part of the closure off the bag when you're not using it. Leaving it on the bag all the time will slowly relax its grip and allow air to start leaking in. The last thing I keep track of with the bag is glue buildup in the grooves of the platen, mainly right around the exit hole. If glue blocks up these grooves, the air can have a hard time getting out of the bag, which can make the pump cycle erratically. This erratic cycling of the pump is the #1 problem that can develop with a vacuum system. It's nothing major and is easily remedied if properly understood. Erratic pump cycling is almost always caused by a condition I call flow restriction. Let me demonstrate. I'll take this little wad of paper and jam it in the hose, making like I'm simulating some wood chips jammed up here. Let's watch what happens with the pump. Hear how it's going on and off and on and off over and over? See how the needle on the gauge goes quickly up to full vacuum and then swings way back down, only to turn on immediately again. Because there is a restriction in the line, the vacuum pump quickly reaches full vacuum and shuts itself off. But the bag is lagging way behind. As soon as the pump shuts off, the air in the bag leaks by the restriction and the hose and turns the pump right back on. Of course, the pump runs right back up and shuts off again. This on-off cycling continues until the bag finally catches up with the pump. This same scenario can be caused by a clogged filter jar, as well as glue filling up the grooves in the platen right around the exit hole, or anything else that does not allow the air to get out of the bag quickly and efficiently. Like a sealed form with air trapped inside. This may never happen to you, but if it does, you'll have a clue about what's going on. Let's go back and take a look at the items we pressed up earlier. Here's the cove and ogee molding I did earlier. Look at the way the bag bent the veneer over these edges. A little sanding and this will look real sharp. The radius edge round table, nice and tight, no bubbles. I think this looks great with the grain going right over the edge like this. Here's the arch jamb. All the laminations are tight, no gaps. Let's take a look at the spiral staircase stringer. We glued this up yesterday, so the glue is quite hard now. I'm going to take it off the form. Steve, could you help me with the clamps? All right. Got that? All right. Set it down right here. one thing I'm going to try is I'm going to blow a little compressed air into this, and it will puff up the bag a little bit. Makes it a little easier to get the laminations out. We'll hold the bag and we'll pull this out here. Go ahead. There, that looks quite good. I think this says a lot about the power and versatility of vacuum. Imagine all the clamps it would have taken to do this conventionally. Well, that's about it. We've covered a number of projects that demonstrate a vacuum press's ability. I hope I've shown you what can be done in a vacuum and inspired you to try your hand at some more difficult applications. It's amazing that such a simple process can do so much. As a woodworker friend of mine said, the versatility of this process is only limited by the imagination of the user. So, imagine away.